Hey everybody, what's up? It's Alex here. We're gonna do a Pangram Java tutorial today. It's gonna be sweet. If you don't know what a pangram is, I had to look it up too. It's a sentence that contains every letter of the alphabet. So they're great for learning handwriting or typing, like the lazy brown fox jumped over the quick dog. That's wrong. But the program me and you are gonna write together today is given a sentence, say whether it's a pangram or not. Hey, my name is Alex. Welcome back to my channel. If you're new here, I make a Java tutorial on this channel just like this one every single week. So if you're new here and you might be interested in that, then please consider subscribing. Let's start off this Pangram Java project by going to File, New Java Project. Call it something like Pangram. And then inside of it, go to New Class. And call it like Pangram. Hit this first check mark, public static void, and then hit finish. Say we have a string. We're just gonna go inside of our main method here because whenever we click the green run button, it runs code inside of these curly braces of the main method. So if we print out, say any sentence, this is a sentence. If we save it and run it, it'll get printed out. But we want to see whether any sentence is a pangram or not. So instead of printing this out, we actually have to store this as a variable. And a good variable to store words like this is called a string. I'll call it like string s equals whatever we want. In this case, I am actually going to replace it with an actual pangram just to add a little spice. Let's move this over a little bit. There are a few ways we could approach this. And a lot of them may not be entirely obvious on what to do with this. In my head right now, I'm just thinking we could loop through this string, get each character, and then keep track of whether each character in the alphabet is hit at least once, kind of like marking off which letter has been found so far. And then if all of them are found, then we can say that it is a pangram. But there may be a few little tricks that we may have to overcome in order to do this. A common approach that other people have done this is through marking off the letters in the alphabet, creating an array of Booleans to represent each letter in the alphabet. So that's the approach we're going to do today because it seems to be the cleanest, and it's also a great program to just like practice seeing how all the code works. And of course, I'll be walking you through it all line by line, even at the very end after we run the program, just to make sure that you know exactly what's going on. So let's create our empty alphabet of Booleans. So we can say Boolean, call it mark, equals new Boolean, and we'll set it to a size of 26 for 26 letters in the alphabet. We're calling it mark because we're gonna mark whether each letter is found. Now let's loop through this string and see what characters we are bumping into. So I'll say, just like any regular for loop, something like we start at 0 and we want to go until the length of this string and go up by 1 each time. And just print out whatever character we bump into. So we can say s.char at to get the character of the position in the string. So if we save and run this, then we now get each and every character. It's because in the for loop, I is keeping track of every position. So it starts at 0, and then 1, 2, 3, all the way up until the very end. So we're getting the character at position 0, T, print T, position at 1, 1, print H, all the way to the very end. Now what we want to do is we want to mark in our little blank alphabet where it is. So T should go to whatever position in the alphabet it is and set that to true. And it's kind of tricky to do this because it's not really taught in schools this way very well, but you can actually get the index of the alphabet by subtracting characters. It's super weird. Instead of printing the character, we subtract like the character A, save it and run it. Then we get numbers. It's because each character has a certain value. Each ASCII character has a certain value associated with it. So if you take the difference like this, it'll tell you the position in the alphabet. You see weird ones like -33, 39, and 36, which are outside of between 0 and 26, the alphabet range. You get those because a capital A is different than a lowercase a. In this case, since T is uppercase, it works fine, and this should be correct. T should be at position 19. So what we can do to handle that is just say, if the character is between capital A and capital Z, do the subtraction with capital A. If it's between lowercase a and lowercase z, do subtraction with lowercase a. So all the indexes are correct. So if the character is greater than capital A, s.chart@ is greater than or equal to capital A, and the character at our current index is less than or equal to capital Z, then we know it's between the ASCII characters capital A and capital Z. And we can create an index variable equal to the character minus that capital A ASCII character offset. And we'll just set that up right here. Here's a pro tip. If you see a bunch of the same code, like s.char@i, 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 if you see it in more than like 2 or 3 places, you can make your code a lot cleaner and easier to understand if you just create a variable for it. So I'm just going to say that char c, like the current character, is equal to s.char@i, and then just replace everywhere you see that with c. Now it looks a lot better. I actually call it like current cur, so it's a little more clear. We handled capital letters, but we'll also handle lowercase letters by doing the exact same thing, except if it's between lowercase a and lowercase z, then the index will instead be offset by the lowercase ASCII character a. If we save this and then print out what index is, then we should see some interesting things happen. We start seeing numbers between 0 and 26. 25? 20, I think 0 and 25, yeah. So we see a Z here, and we've got 25. The last index is 6. It's a G, A, B, C, D, E, F, G. G's number 7 if we start at 1, but since indexes start at 0, everything is all matched up. So now rather than print it, we can just mark off where we see it in our little blank alphabet. So we can just say mark of index is equal to true, since all this code's being run for just one character. And so we'll keep going through this for each and every character, marking true when it sees the letter. So to see what's going on, we can print out mark, but I think this will just print out, yeah, that'll just print out the weird memory object for the array. So we can just for loop through it and say, since our empty mark array starts at 0, we'll start at 0, and we'll go up until the length of that, 1 by 1, and print out whether each one is true or false. So we'll say mark of I, whatever value it is at that index. So we'll save it, run it. We see a bunch of trues here, which is good. This is true if A is found, this is true if B is found, this is true if C is found, all the way up until Z. If this was just, say, A, B, C, add a little capital in there. If we save it and run it, then we see A, B, and C, but not everything else. Can't find everything else. This is exactly what we want, and I'll just put it back to that actual pangram. Instead of printing it out, we can just see if any of them are false, then we know it's not a pangram because it has to have everything. So if mark of I is equal to false, then we'll create a variable pangram, set it equal to false. We'll just create a Boolean pangram and set it equal to true. So it'll assume that the string is a pangram until it actually sees that one of them is not marked. Lastly, we'll just print out pangram. And this will print out true or false on whether the string is a pangram. So save it and run it, and we see true. It is a pangram. If we remove the Z, then run it, you'll see false because it doesn't have the Z. It needs to have everything there. If we want to be a little fancy, we can just say if it is a pangram, then we can add a little message like, yay, it is a pangram, fam, else sorry, not pangram. Like that. So now I'll just show you the entire code in all of its glory. I'll zoom out a tiny, no, I'll keep it this size, but I'll walk you through it step by step exactly what's happening. So when we click the green run button, it goes into the code inside of the main method, and then it goes line by line. So the first line we see is a string S is set equal to this sentence. And it looks like the sentence is, the quick brown fox jumps over the lazy dog. We see some capitals in here and some lowercases. Next, we create a Boolean array called mark, and they're all set to false right now. It's the size of the alphabet so that we can mark everywhere. We have a Boolean pangram set to true, and an index set to 0. So the first 4 lines of code are just setting variables. Next, we get into a for loop. We start at 0 and go to the length of the string. We declare char cur for like current variable is going to be the character at index I. This is just a string method. So you do string dot, and then this is one of the methods that gets the character variable at a specific index for the string we have. So since we start at 0, s.char at 0 is capital T. So right now, cur is capital T. We found out that characters have certain number values associated with them, so we can kind of treat them like numbers. So they can be between, say, capital A and capital Z, or lowercase a and lowercase z. So if the current character, in this case capital T, is greater than capital A and less than capital Z, then it's in the capital ASCII characters. In this case, capital T is between them. So we set the index equal to capital T minus capital A, which is just the distance. And we mark that index in the mark array and set it equal to true. And that's one iteration. And next we go to H. And it does the exact same thing. We see lowercase h. I is now 1, which is why we get lowercase h, because it's s dot character at 1, not 0. Cur is h. H is not between capital A and capital Z, but it is between lowercase a and lowercase z. So the index is lowercase h minus lowercase a. And we mark that in the Boolean array here. And we go all the way through and do its thing all the way up until G. That's really the magic part. If you learn anything from this video, this is really the secret sauce. Next, all it is just seeing if they're all true. If each letter is marked, then it's a pangram. So we want to check each Boolean variable inside of marks. So we start at 0 and go to the length, which is 26. If it's false, then just set pangram to false, because if any of them are false, it's not a pangram. If there's everything but no A, sorry, it's not a pangram. If there's everything but no P, sorry, it's not a pangram. And that's why we have pangram set to true up here, because if there's just one false, the whole thing's false. But if there's one true, then we really don't know. And lastly, we get to this if statement. If pangram is true, then we'll print this little message saying, yay, it's a pangram, fam. Otherwise, pangram's false, and not all of them are marked. So we say, sorry, not a pangram. And I'll just test this one more time with you. Maybe, I don't know, do like some letters, see if that has all the letters of the alphabet inside of it, run it, and no, it doesn't. If you enjoyed this program, please leave a like. Thank you for letting me teach you, and I'll see you in the next video. Have a great day.